Okay, continuing with the UN report or Antonio Guterres' call for extreme heat action plan. I panicked a little. This is a footnote which defines heat wave. A heat wave is an extreme heat event defined as a marked unusual period of hot weather over a region persisting for at least 2 consecutive days during the hot period of the year based on local climatological conditions with thermal conditions recorded above given threshold. So this comes from preventionweb.net and so on. Each agency, then let's say the India Meteorology Department tends to have its own definitions, but it basically again relies on local climatology exceedances, whether it should be 95th percentile or a certain number of degrees above the background expected and how long it should stay and so on and so forth. Obviously, urban hotspots emerge during extreme heat because of the urban heat island and lots of other exposure issues like infrastructure, population density, etc. The world's cities are heating up twice the global average rate due to rapid urbanization and urban heat island effect. So heat waves present an acute danger to urban centers where structural, socio-economic and demographic factors magnify their impacts. Urban areas house more than half of the world's population, and another 2.5 billion people could be added to urban areas by 2050 and so on. So I'm not a big fan of these 1.5 degree things. At 1.5 degrees C of warming, 67 cities will experience 150 or more days a year of temperatures exceeding 35 degrees C. Under 3 degrees C of warming, it rises to 197 cities. As I said before, the skills of the models is good at regional scales. Then you are doing warming of 1.5 degrees C, and then you have scenarios associated with them and so on. But nonetheless, the main idea is how can you produce actionable information at the scales you need, at the city level you need. So if 3 degrees C of warming in the current climate with the current cities may do something, or in the current land use with current urban centers, it may do something, but as you go forward, lots of other factors come in. Population is expected to increase, urbanization is expected to increase, urban population is expected to grow, and so on. And yet there are lots of uncertainties. So it's about what information can be used to actually plan for things, right? So the impacts of extreme heat will not be evenly shared between or within cities, and addressing thermal inequality is an urgent challenge. Okay, a 700% global increase in the number of urban poor living in extreme heat conditions is expected by 2050, with the largest increases across West Africa and Southeast Asia. What do you do with this information? It's at a very large scale. West Africa is a large region, and which regions will urbanize by 2050, and how the socioeconomics, vulnerabilities, exposures and responses will change to determine the risk is not always very easy to do at local scales. You can downscale climate, but you cannot easily downscale the risk. If you do risk at a larger scale, you cannot simply find a way to downscale them. That's tricky, okay? IPCC loves these kind of figures. The extent to which current and future generations will experience a hotter and different world depends on choices now and in the near term. So you have a scale running here of global temperature change above 1850 to 1900 levels. So that's the baseline. So you started with anomalies, global mean anomalies that were cooler, and then you started jumping around the zero line here in the 1940s, and since the 1970s or 80s we have been consistently warming, especially when you look at decadal averages. So the 2011-2020 was around 1.1 degrees C warmer than the baseline of 1850 to 1900. Future emission scenarios then come into play, and depending on where you go, the uncertainties of these ranges depend on the scenarios themselves. But in the early periods out to, let's say, 2030, 2040, They depend on internal variability, model uncertainties, and so on. But it all comes down to dealing with this kind of projections or information. So born in 1950, you are 70 years old by 2020, and you have increased exposure here in terms of temperatures. Born in 1980, you are going to experience that in 2050. If you're born in 2020, then you're going to hit very soon some extreme heat years, especially if you live out to 2090. Then you are going to have, you know, various levels of future experiences depending on how we address climate change, which means the scenarios, right? So those are all uncertain, but again, can anybody really plan out to 2100? Maybe the urbanization can be done better planned urban greenery in buildings, infrastructure, heating, cooling plants, and so on and so forth. Nice rain beginning to start. Maybe I'll show you the video if it sustains. Extreme heat is a silent killer, so at-risk population here will read further. Anyone can be impacted by heat, but some people are disproportionately exposed to and impacted by extreme heat due to physiological factors, as we said, young, the old, women, and poor, and so on. Heat stress is the leading cause of extreme weather-related deaths. Acute and prolonged exposure to excess heat causes heat stress on the body and exacerbates underlying illness, including cardiovascular disease, diabetes, mental health, asthma, and kidney diseases, and can increase the risk of accidents, adverse pregnancy and birth outcomes, and transmission of some infectious diseases. There is also evidence that violence goes up. Domestic violence may go up. Of course, we'll see in a minute that number of school days or increased number of school closings, which can lead to other problems, and so on. So termed the silent killer, extreme heat dwarfs the impact of more visible weather hazards. We will not read all the numbers, as I said. So between 2000 and 2019, approximately 489,000 heat-related deaths occurred each year, with 45% of these in Asia and 36% in Europe. This we already mentioned, but worth mentioning again, and also reminding ourselves that attributing deaths to heat waves is tricky. The lack of uniform reporting standards makes the aggregation and comparison of nationally reported statistics challenging. WMO tends to have protocols set up, countries sign up, but doesn't always happen. So what are the at-risk populations? People living in poverty, older persons, those with pre-existing health conditions including mental health, and persons with disabilities, women, pregnant women, infants, and young children. Workers, particularly outdoor workers, those in physically demanding roles, or those working in unventilated indoor environments, and so on. So physiological factors, exposure factors, and gender all play critical roles. I won't read all the details, but UNICEF found that by 2050, if the current trend continues, almost every child under 18 in the world, nearly 2.2 billion, will be exposed to high heat wave frequency, up from only 24% of the children in 2020. Despite all the uncertainties in projections, we have to plan this because children are the future is theirs, and we have to protect them, right? Heat-related mortality for people over 65 years of age increased by approximately 85% between 2000 to 2004 and 2018 to 2012. Two periods compared, 85% jump in heat-related mortality. This is very clear in many places, and often you get drought forecasts, for example, in villages. Old people may know that this could be their last summer. Okay, so this is really unfortunate because often you cannot just move them en masse. You don't have shelters or treatment centers or ways to protect them, and so on and so forth. Okay, humid heat risks, of course. High heat combined with high humidity limits the human body's main cooling mechanism, which is evaporative cooling through sweating. Reduced evaporation of sweat from the skin when temperatures warm and humidity increases. This accelerates the accumulation of heat stress in the body, making exposure to high heat and humidity dangerous. Thermal heat stress indices such as wet bulb globe temperatures, universal thermal climate index, heat index, and humidex are used to estimate the level of heat stress that a person may experience in a given environment due to a combination of heat, humidity, and other factors. As heat stress increases, it will degrade thermal comfort, livability, and even human limits to survivability. So you cannot just look at temperatures, you have to look at thermal heat stress by including humidity and worry about wet bulb temperature changes and so on and so forth. In terms of the impacts, I'll come back and do it in the next podcast because this is already 11 minutes long, but you get the idea. I am looking at dark because suddenly it started raining, mostly windy. You can probably hear the sound of the rain, but there is some rain. It's not very high. Our own forecasts say that the rain will not be extreme, but there is rain. So we'll come back and continue this discussion on the impacts of heat waves. Okay?